What we're going to do is we're going to look at real numbers. In algebra, this is the first thing that we want to make sure we understand because in order to talk about the vocabulary, we need to know what the different numbers are. So the first numbers that we're going to talk about are natural numbers. And natural numbers start with 1 and they keep on continuing. 1, 2, and so on and so forth. So we would put that in the Venn diagram 1, 2, 101. Those would be an example of natural numbers. The next ones would be whole numbers. Whole numbers start with 0 and then they include all the natural numbers. So if we're looking at the Venn diagram, we have our natural numbers, and then whole numbers would include all of the natural numbers plus 0. The next one would be integers. Integers are positive and negative whole numbers. So we would include the natural numbers, we include the whole numbers. What integers add would be the negative numbers, like -1, -15, -206. Those would be included in integers. Now, rational include fractions and decimals where we know the ending digit. An example would be 0.56 or 0.333 repeating. Notice that we know the next digit is 3, so that would be a known decimal. An unknown one would be an example of 0.5673, and it continues. That would be an example of something that would be irrational. The most famous irrational would be the number pi. We could have another one which would be like the square root of 2. If we put that in a decimal, that would also be an irrational number. Real numbers are all the numbers that we're working with in algebra. When you move into advanced algebra or algebra 2, an example would be an irrational number where we're talking about the number I. But in algebra, we're only going to be dealing with real numbers. So what we're going to do is, for example 1, we're going to fill in the Venn diagram with our different values. So the first one, we have -6. That would be an integer. So I'm going to put -6 in with z. 5 would be a natural number. 0 would be a whole number. The square root of 9 is kind of a tricky one because the square root of 9 is 3. So that would actually be a natural number. So even though it's a square root, we're putting it in for the natural number. The square root of 11 would be an irrational. We don't know the square root of 11, so that would be an irrational number. -6/2, of course, is -3, so that would be an integer. Even though it looks like a fraction, it can be reduced to an integer. So that's why we're putting it in the integer area. 8/3 cannot be reduced, so that right there is going to be a rational. And then 4.111 repeating, we know the next digit is 1, so that right there would be considered a rational also. For our last one, we don't know what the next digit is, so that's why we would include it as irrational. Now, for the next example, this is going over the summer packet stuff. We're just going to go over basic adding. When we're looking at this, we have 8 negatives plus a -2 would be 10 negatives. -4 plus 1 would be -3. If you get confused with what you could do is you can write out the negatives. 4 negatives, 1 positive. A negative and positive add up to 0. So what we're left with are 3 negatives. In the same way, if we had 6 negatives and we have 3 negatives, we have a total of 9 negatives. Letter D, we have 2 positives, we have 5 negatives. These, of course, become 0, so what we're left with is 3 negatives. And then if we look at the next one, we have -9 and +12. That would give us a +3. I almost put a -3. So if we're looking at a rule for the pattern, what we know is same sign, we add, and different signs, we subtract. Notice we have same signs, we're adding those, different signs we're subtracting, same signs we add, different signs we subtract, different signs we subtract. Now, when we're looking at subtracting integers is just going to be like adding integers. The only difference is I'm going to treat a subtraction as a negative. So I have negative 3 minus 1. I'm going to treat that as negative 3 plus a negative 1. I see the same sign, so I know I'm going to add it, and that gives me a negative 4. I'm going to go 2 plus a negative 5. That's going to give me a negative 3. Now, negative and negative is a positive, so that would be a positive 1. If I subtract a negative, I'm actually really adding 1. So negative 2 plus 1, notice different signs. I'm subtracting. Larger number is negative, so that's why it's a negative 1. Negative negative gives me a positive. Some students just like to put a plus sign when they see the two lines. And so we have different signs. We're going to subtract. And if we subtract a negative, it becomes a positive. So that would be a positive 1. If we're looking at the next ones, negative negative is a positive. So that would be 0. 1 minus 2, that would be 1 plus a negative 2. Different signs we're going to subtract. If we subtract a negative, it becomes a positive, so that'd be a negative 6. Subtract a negative, becomes a positive, so that would be positive 1. And then for our last one, negative 1 plus a negative 4, same signs, we're going to add them, so that would be a negative 5. Now, the last thing that we're going to do is order of operations. If you remember order of operations, parentheses first, exponent second, multiplication and division, and adding and subtracting. Those are our 4 steps. So when we're looking at our first problem, first thing I'm going to do is multiply. So I have 10 minus 18. And remember, if I subtract, that's the same thing as adding a negative. So that would be negative 8. If we have division and multiplication, it always goes from left to right, just like reading a book. So 6 divided by 6 is 1. And then if we times it by 5, that gives us a 5. And then for the last one, we're going to do the parentheses. 1 minus 3 is negative 2. Then I'm going to square it. That gives me 4. Now I have to decide add, multiply. I'm going to multiply before I add. So that gives me 4 plus 32. And when I add it up, I get 36. So this right here would be the real numbers.